Hi friends, welcome to session 9 on sequences. So this is the chapter of Bsc second semester of Gulbarga University, Kalaburgi. So in this session we are going to study problems on divergent sequence. Take one example. Find the least positive integer m such that mod of xn minus 1 less than 1 by 10 cube for all n greater than m, where xn is equals to 1 plus minus 1 raised to n divided by 2n. So first you have to find the positive value of m such that this equation satisfies. So here first mod xn minus 1. Mod xn minus 1, so you have to substitute the value of xn. Xn is 1 plus minus 1 raised to n divided by 2n, and this minus 1 plus 1 minus 1 get cancelled. It is simply mod of minus 1 raised to n divided by 2n. So it is mod of minus 1 raised to n is simply it is 1 divided by 2n. So what is given here? It is given that mod xn minus 1 is less than 1 by 10 raised to 3. So this implies this mod xn minus 1 is less than 1 by 10 raised to 3. So this implies here mod xn minus 1 value what we got here 1 by 2n. So this implies 1 by 2n is less than 1 by 10 cube it is. This is 1 by 10 cube it is, not 103 it is like. So now this implies, or it is like this here, 1 divided by 10 cube it is. So this implies if you take reciprocal, it becomes 2n greater than 10 cube. So you know I told you this many times, if 2 is less than 3, if you take its reciprocal, 2 by 3 is becomes 1 by greater than 1 by 3, because 1 by 2 is 0.5 and 1 by 3 is 0. This is 333 it is. So 0.5 is greater than 0.33. If you take reciprocal, it becomes this inequality changes, 2n greater than 10 cube or 2n greater than 1000. So this is n greater than 500 divided by 2, 1000 divided by 2 it is. So on taking m equals to 500, we can write this mod of xn minus 1 is less than 1 by 10 cube for all n greater than equals to m. The value of n itself is m here. Let us take one more example. By definition, show that the sequence xn diverges to infinity. Here xn is equals to n. Take this as equation number 1. Let k greater than 0, however large, be given. Then by Archimedean property, there exists a positive integer m greater than k such that for all n greater than equals to m and m greater than k, we have n is greater than k. This is the property. So that is n greater than k for all n greater than equals to m. And this implies here xn. See here xn is equals to n and n is greater than k. This implies xn is greater than k from equation number 1. So because here in equation number 1 what is given? Xn is equals to n, and this implies here xn is equals to n, and here we have n, and in this equation n is greater than k. This implies n is greater than k. So xn is greater than that is n greater than k for all n belong greater than equals to m. So this implies xn is greater than k for all n greater than equals to m. This is by equation number 1. So it means limit as n tends to infinity, xn is equals to infinity. Hence the sequence xn diverges to infinity. Let us take one more example. Using the definition, show that the sequence minus n square diverges to minus n infinity. It is also similar. So let us take, let k greater than 0, however large, be given, and here xn is minus n square. This implies here xn is minus n square and xn is less than minus k. So this implies because it is negative value, no? So it is xn is less than minus k, and this implies minus n square is less than minus k. And if you remove this negative sign, you know, if you remove negative sign, it becomes this inequality again changes. So n square is greater than minus 2, and I'll tell you here how it is like this. So here you know minus 5 is less than minus 3. If you take plus, it becomes 5 is greater than 3. So therefore this one minus n square less than minus k implies n square is greater than 3. This implies n is greater than this one here. This n is greater than under root of k it is. So if we choose a positive integer m which is greater than root k, we have xn is less than minus k for all n greater than equals to m. So that is limit as n tends to infinity, xn is equals to minus infinity. So hence the sequence minus n square is diverges to minus infinity. Take one more example. It is also similar. So show that the sequence 3 raised to n diverges to plus infinity. So here it is xn is equals to 3n cube, and here xn is greater than k because it is positive value. So xn is greater than k. This implies 3 raised to n is also greater than k. So take log on both sides because you want the value of en. No? Taking log on both sides, log 3 raised to n is greater than log k, and it is log m raised to n is n log m, that is n log 3 greater than log k. So this implies n is greater than log k by log 3. So that is, if we choose a positive value integer m which is greater than log k by log 3, then we have this xn is greater than k for all n greater than equals to m. So thus this limit as n tends to infinity, xn is equals to infinity. So hence the given sequence 3 raised to n diverges to plus infinity. Let us take some more examples. Show that a constant sequence converges to c. Here xn is c for all n greater belongs to n. So take c in this side, xn minus c is equals to 0 for all n belongs to n. For every epsilon greater than 0 and for all m greater belongs to n, we have this mod xn minus c is equals to 0, which is less than epsilon because here epsilon is greater than 0. So now mod xn minus c is less than epsilon for all n greater than equals to m. This implies, if you apply the definition, so you know mod xn minus l is less than epsilon. This implies limit as n tends to infinity, xn is equals to l. So here limit as n tends to infinity, xn is equals to c. Hence the given sequence xn converges to c. So take one more last example. Show that the sequence 2n plus 5 divided by 3n plus 8 is bounded. So first you have to see, first you have to take this one as xn. Now here this n is positive integer. Since n belongs to n, means n is a natural number. So this is a positive integer, so therefore it is definitely greater than, this is a positive number, 2n plus 5 is positive and 3n plus 8 is also positive, so therefore this ratio is greater than 0. That is, this implies this xn plus 5 is nothing but, this is xn is greater than 0. That is, this implies what? Xn greater than 0 or 0 less than xn. So what this implies here? All the values of xn is greater than 0 means it has a lower bound. So therefore this implies the sequence xn is bounded above. क्या है इसमें? सारे xn का value क्या है? Greater than 0. 0 से ज़्यादा है. This means here it is bounded below. Lower limit पता है हमको. So now and also let us इसमें एक 1 minus कर देखेंगे. Then we will see whether it's positive or negative like that. So 1 minus 2n plus 1 minus 2 minus कौन सा भी कर सकते हैं हम लोग. Let us take minimum only. 1 minus 2n plus 5 divided by 3n plus 8. Take LCM and simplify, you will get n plus 3 divided by 3n plus 8. It is also positive. So this implies 1 minus 2n plus 5 divided by 3n plus 8 is greater than 0. So this implies, take this term in this side, becomes 1 greater than 2n plus 5 divided by 3n plus 8. Means, so 1 is greater than xn or xn is less than 1. So xn is less than 1 means here xn is less than 1. I told you here. So xn is less than 1. 1 से छोटा है ये. So 1 से छोटा है, 0 से बड़ा है. So means if xn is less than 1 means it is bounded above. Hence the sequence is bounded above, and hence the sequence is bounded below and bounded above. That is here what we got, xn is here we got xn is greater than 0 and less than 1. So from this we can say that the sequence xn is bounded. So this is all about this today's session. So thank you very much for watching this video. In the next session we will see some more examples on this topic. Thank you.